Before we jump into psychophysiological interactions, or context-dependent correlations as they're referred to in AFNI, we're going to cover a command called waiver. What this does is it creates an ideal response, such as a gamma response or a canonical HRF, hemodynamic response function. This is essentially the same thing that happens in 3D deconvolve and what gets fitted to your time course, and it's output from the X1D option if you supply that. But with waiver, it's just a quicker way to do it. It's not supported that much anymore because 3D deconvolve does a lot of the same things it does. But for the physiological interactions we're going to do, we're going to use waiver. So here we're going to cover a few functions of waiver and how it might help your intuition about how these ideal time courses are generated. The basic usage of waiver is the command, and then DT. You could also do TR. Stick with DT, and that's your time step. So here it's going to be 2, so every 2 seconds. And we next supply a basis function, like a gamma function. And there we have a couple different options after that. One is called the inline function, where we specify when a stimulus is on and for how long. So here we could say we want a value of 1 at the very first time point. And if you want to visualize this, instead of dumping everything out to standard output, which would just be a bunch of numbers, we can feed this into 1D plot. Make the lines thick and refer to standard input. So here's what it looks like. Okay, so this is the first time point. This is the first 2 seconds. And then it goes up for a couple other TRs, starts to come down for a few TRs, and then returns back to baseline. Remember, on this x-axis, it is in TR, so this is seconds. The entire thing takes about 16 seconds. Likewise, we could also use an ideal response function created by Bob Cox, a developer of AFNI. And this is pretty similar, but it also includes an undershoot, a post-stimulus undershoot. So you can really use whatever one you want there. Another option you can have is something called T-stim. So if your stimuli are not locked onto your TRs, so for example, if your TR is 2, but you had a thing occur at like 3.2 seconds, or something occur at 10.5 seconds, or something occur at 20.37 seconds, that's okay. Just use the T-stim option. Also, if you don't provide any basis function, it's going to assume that you're going to want the gamma function. So just leave that empty. Again, feed this into 1D plot. So you can see here, at about 5 seconds, bumps up, goes back down a little bit, comes back up. I guess they're in TR, sorry. And then later on, about 11 TRs, there's another bump. So that should give you a pretty good insight into how these ideal responses are created, and also there's some overlap in how they convolve with each other. One last example, just using that. I'm actually going to give it an expression. So let's just forget a basis function. We're going to create it ourselves. And it's essentially like 3D calc if you've used that before. But here, T stands for time. So on the x-axis, time, let's say to the 8th power, times e to the negative t divided by 0.5. These are roughly the same parameters that you'll find in the waiver help file for generating that ideal hemodynamic response function, essentially an impulse function. And again, I'll feed that into 1D plot. Okay, so it's very smooth. Again, we didn't feed it any TR or anything, so it's going to be very, very finely sampled at the temporal resolution. Okay, so that's pretty much what an ideal response function looks like, and that's how you can mess around with it with waiver. So that's the command. We're going to be using it a little bit more in detail when we get into psychophysiological interactions, but it's a very useful program to work with and just mess around, see what happens when you have stimuli that are very close to each other, very far apart from each other, and also either on the TR or off the TR. I hope this helps you build your intuition and gain a little bit more appreciation for what's going on. It's okay if you don't have more appreciation, though.